Hi, in this video, I'm going to talk a little bit about configuring speed, duplex, and MDIX on Cisco switches. Okay, duplex communications. So switches today do bi-directional communications, full duplex, so they can send and receive simultaneously. Used to be in the old days hubs, right? We had unidirectional communications, half duplex, so they could only send or receive, and then we'd get collisions if both sides tried to send at the same time. But today's switches, especially with gigabit Ethernet and 10 gig Ethernet NICs, which actually require full duplex communications to operate, most switches nowadays, or just about all switches nowadays, actually default to full duplex. So let's talk a little bit about how this occurs. So switch ports can actually do half duplex or full duplex. If we leave it to auto negotiation, which we tend to do when we are connecting to a device like a computer in this case, if both NIC cards can do full duplex, then they will auto negotiate full duplex. As far as the speed goes, they will auto negotiate the highest speed that both can perform at. So in this case, that would be 100 megabits per second. And auto negotiation is fine. It's actually very good if you're connecting to an end device, because somebody might plug a hub in there and that would operate in half duplex by default. But when connecting to another switch, we typically want to configure those settings manually. So I'll explain more about that in a moment, why we want to do that. But the commands to do so is under the interface or interfaces, the range of interfaces for the switch ports. We would typically manually configure the speed. So this is when we're configuring the port when it is configured or connected, excuse me, to another switch. And we'd also set the duplex, and of course we'd want that to be full. Okay, so the reason why we tend to want to do this manually when connecting two switches is that mismatched settings for duplex mode and speed, especially duplex, can create some connectivity issues. And if we leave it up to auto negotiation, if there's any kind of failure in the auto negotiation, then that's going to create some mismatched settings and we're going to have some problems. And I've seen this occur many times. Not in so many times that this is a real problem, having the two switches auto negotiate their duplex and speed between them. But I've seen it enough where, well, let's put it this way. It's easier, it's best just to manually configure it, and that way you don't have to worry about it. Okay, so why would a duplex mismatch be a problem? Well, if you have one switch that has its interface configured full duplex, so it says, you know, and maybe this happened during auto negotiation or manually, but hopefully not manually. You know what you're doing, you did both sides full. But if there is a duplex mismatch for whatever reason, the full duplex side can say, you know what, I'm going to send whenever I want to because I'm full duplex. The other side says, I'm half duplex. I can only send when the link is clear. So I will wait for the other side not to be sending, and then if it's not sending, I can send. Now the half duplex side, switch 2 in this case, would think that the switch 1, the other side, is also half duplex and playing nicely. So S2 would think, you know, if I'm sending, S1 wouldn't send because it would realize, being half duplex, that I'm sending, and it will wait to send. However, S1 is full duplex. It's not playing that game. It's just saying, I can send whenever I want, because it's really assuming S2 can do the same. All right, so what the problem here is that S2 will continuously experience collisions, and more than the normal, because if they were both operating a half duplex, then at least S1 would be waiting to send. But because S1 is operating in full duplex, we're going to get a lot more collisions than normal. Of course, the best thing, have them both operating at full duplex. That's what we want. Okay, so the best practice is to manually set the speed in duplex when we're connecting two switches to each other. All right, so what we do here is, and that I would even say even for dedicated servers and routers and things like that. If you know that other end is not going to change, it's not just an end user device, then I would manually set it to be full duplex and whatever the speed is. So we can do speed ? And that will show you the, for that model switch and well, for that port on that switch, what your bandwidth options are. And again, auto is for auto, but we're going to do the speed 100 in this case. Duplex, we can see auto, full, or half. We want full. And on the other side, we're going to do the same thing. Configure it for speed 100, duplex full. Okay, there's also Auto-MDIX. So as you know, when we have two like devices, like two switches interconnected, they typically require a crossover cable. When we have two unlike devices, like a switch and a router, or a switch and a host, then we have a straight through cable. Now, what about a router and a host? Okay, well, we think of routers as end devices, similar to a computer, just like a host is. So that would also require a crossover. So the more modern Cisco switches support the MDIX auto interface configuration command, which allows you to use whatever type of cable in between them, and it will actually auto detect the cable and what's on the other side, and then so you don't have any problem. My sense is, my experience is, I just like to use the proper cable. Why cause any problems? If you're relying on MDIX and then you replace the switch with another switch that doesn't support MDIX, then you could be, and you have the wrong cable attached and you don't realize it, you're just creating yourself a few more problems. But I'm kind of old school that way. So anyway, MDIX, okay, requires the speed auto and duplex auto commands, and then MDIX auto. So I tend to prefer setting the speed in duplex manually and then not worry about MDIX. Okay, but it is enabled by default on many of the newer Cisco switches. Okay, to verify the MDIX settings, you just do show controllers command, and that's where actually you'll see that. You won't see it in the show interface command. You need to do show controllers, Ethernet controller, and then the port number. In this case, we're doing fast Ethernet 01. We're saying include Auto-MDIX. So instead of show controllers, there's a lot of information. This pipe include Auto-MDIX. You got to get it exactly right as far as the spelling. Will only display the lines that match Auto-MDIX. Okay, so any line that has Auto-MDIX in it. Okay, so just some other troubleshooting commands. Show interface command. All right, that's always very useful. You want to make sure that your line protocol and status are up and up. If you see up and down, then there's either an encapsulation type mismatch, or the interface on the other end could be in error disabled mode, or there could be some kind of hardware problem. If you see down, then typically the cable is not attached or some other interface problem exists. And if we see administratively down, then we forgot to do a no shutdown. All right, as far as looking down here, we see Runt's Giant CRC. A runt frame is an Ethernet frame that is received shorter than 64-byte minimum. That 64-byte minimum goes way back in the days when we used to use hubs and half duplex and have collisions. We had to make sure that all, minimum cable lengths or maximum cable lengths, I should say, maximum distances between end devices and hubs and everything. It all has to do with being able to send that last bit out of that frame, and knowing if you send that last bit out and there's no collision detected, then if there are any collisions after that, it's not your frame. So that required, long story short, it requires things like a minimum Ethernet frame size of 64 bytes. Giant frames are longer than the maximum allowed. They're called giant. This can actually because of a bad NIC. CRC errors are when there's some kind of error, typically on the media or cable, or could be even the interface. Okay, so collisions. If you are operating in full duplex, you should not see any collisions here. Okay, collisions, by the way, are not errors as far as half duplex. So if you have the switch connected to a hub, you should see collisions. That's just a normal part of Ethernet operations. Late collisions means that is a problem. That means the switch is detecting collisions after it should. That usually means either the cable is longer than it should. Again, that gets back to what I was talking about earlier, why we have minimum frame sizes and being able to detect collision before that last bit of that frame goes out. Okay, so usually the reason we start seeing collisions on a switch port is that either we are properly operating in half duplex, excuse me, because we're connected to a hub, or we're improperly connected in one of the two ends is half duplex and the other end is full duplex. And that would be a problem. Switch to switch, just do full duplex. All right, that's a little bit on configuring speed, duplex, and MDIX, excuse me, on Cisco switches.